Good morning, good afternoon, good evening. Welcome to chapter 34. We're making a pretty big jump from our previous chapter. The previous chapter we talked about different systems, or the several chapters we talked about recently were different systems within a single organism, and now we're going from a single organism to this thing called an ecosystem. An ecosystem is a collection of organisms, of all living things in an area, plus the physical environment in which they live. So all the living things, all the plants, all the animals, all the bacteria, fungi, all interacting with one another, plus them interacting with the soil, interacting with the water, interacting with the physical elements of the environment. The entire livable surface of the planet, where all of these ecosystems are located, is referred to as the biosphere. The biosphere has three basic components: living things in the air, living things in water, and living things on the earth. The things in water are called the hydrospheres. Anything that's alive in water, in all forms of water, freshwater, saltwater, snow, ice, all forms of water. All the living things that we find in water, we refer to that area as the hydrosphere. The lithosphere is where all of the living things that we find on land and in the earth, so things in soil, things on soil, things that live, what we say terrestrial living things. And then last is living things in the atmosphere, and to be honest, there aren't very many things, maybe, I can't think of any to be fair. There aren't very many things that live exclusively in air. Some things spend some time in air, but most things have to either come back to water to live and reproduce, or come back to the earth to live and reproduce. Very few things spend their entire lives in the air. If we talk about this thing called the biosphere, we talk about all the living things on the planet. What I want you to understand before we dive too far into this is that the amount of sunlight an area receives determines the kinds of plants we're going to find in an area, among other things, but the amount of sunlight it receives is important. The Earth, obviously, is struck by light from the sun, but because the Earth is curved, notice that the amount of light in one of these areas is the same, right? So if we say this is 100 light units, whatever we want that to be, we see that at the equator, the sunlight strikes directly, and so those 100 light units are only spread over so big of an area. The further we move away from the equator, either going north or going south, we see that that same amount of light is now spread over a larger area. And when you get to the extremes, the polar extremes, either the South Pole or the North Pole, that same amount of light that strikes this much area at the equator is now being spread over twice as much area. This is why it's so much colder at the poles. Far less energy, far less heat is striking those areas. The light is much less intense. If the light is much less intense, what does that mean for the ability of the plants in that area, in those areas, to photosynthesize? It has to be less. If there's less energy striking any given square meter, that means that there's less energy to be used, and therefore less photosynthesis that can be done. As you move farther away from the poles, what happens is the amount of light striking any one given area is going to be less, and therefore you're going to have reduced photosynthesis. If you have reduced photosynthesis, you're going to have reduced numbers of plants, reduced species of plants, diversity of plants, and if you have reduced plant diversity, you're going to have reduced animal diversity. The amount of sunlight striking an area determines a lot of things, not the least of which being the kinds of plants we find in an area. Because the Earth is tilted on its axis, the Earth, if this is the sun, and this is the Earth doesn't spin around the sun like that. If this is the North Pole and the South Pole, the Earth doesn't go around the sun like that. The Earth goes around the sun like this. So at one point, the South Pole is tilted towards the sun, and when you do that, that means this point is the South Pole is tilted towards the sun. That's when the southern hemisphere has summer and the northern hemisphere has winter. And right now we're around spring, right? So we're kind of intermediate between warm and cold. Well, because we are intermediate, our tilt is pointed not directly at or towards the sun. Once we move on to summer, our tilt, now the northern hemisphere is going to be pointed at the sun. It's more direct, and that means it's going to be a lot hotter. The tilt is what gives us our seasons. If it wasn't for the tilt, we would not have any seasons. It would be the same season based on where you were away from the equator. Here's the sun. Here we see that tilt, right? So in June, the sun is tilted towards the sun, so it's hot. In December, the Earth is tilted away from the sun, so it's cooler for us. Again, the energy is spread over a larger area because we're tilted away. The southern hemisphere is tilted towards it. It's more direct, so therefore it is warmer. The Earth does not go around like this. The Earth goes around like this. I guess I should do it where you can see it like that, not like this. Because of the tilt, because of light intensity, hot air at the equator rises. We know that hot air rises. Hot air rises at the equator. As that hot air rises, it goes up into the atmosphere. As you go further up into the atmosphere, what happens is the temperature, it gets cooler. So this hot air, which holds a lot of water, hot air holds more water than cold water. This hot air rises. As the hot air rises, it cools. The water in the hot air condenses, and when it condenses, it will then rain back down again. Where do we find rain forests? We find rain forests around the equator. Being around the equator because there's so much rain, because A, the equator's hottest, so there's more hot air. That hot air takes a lot of water with it. The water goes up, the water condenses, the water falls out. That's why it's called a rainforest. Now that the water has fallen out of the air, we now have cool air up here without any water in it. It's getting pushed away from the next batch of hot air that's rising up from the equator. So this cool air is now pushed away from the equator, and it drops at about 30 degrees latitude. If you look at this image right here, this is my equator, right? Where are we? Right here in Georgia. Hot air rises. You probably can't see it. If you look at the PowerPoint on your own computer, you can see there's a little cloud right here. This hot air rises, and as that hot air rises, it will cause the water in it to condense, and then the water in it condenses and falls back down, again, right here along the equator, where our rainforests, right here along the equator. This now cool air gets pushed out of the way by more hot air rising. This cool air then drops down at about 30 degrees latitude. And this right here, this line is about 30 degrees latitude. Where are we relative to 30 degrees latitude? We're just above it. We're right in this area, just above 30 degrees latitude. This cool, dry air that drops at 30 degrees latitude, it's what kind of air? It's dry. It doesn't have any moisture in it. So where do we find deserts? We find deserts around 30 degrees latitude. Look, what is this area right here? Northern Mexico. When you think of Mexico, what do you think of? You think of deserts. This is Southern California. This is Nevada. This is Arizona. When you think of Arizona, what do you think? Desert. This is Texas, right over here. West Texas. What is West Texas like? It's a desert. East Texas, Louisiana, Alabama, Georgia, northern Florida, these areas right here, they are not deserts. And the reason why they are not deserts is because we have one saving grace. And this one saving grace that we have is this big body of water right here called the Gulf of Mexico. What the Gulf does is the Gulf injects hot, moisture-laden air into the climate right here. And so when we look at, in a few minutes, we'll look at a map that shows where different ecosystems are. We will see that this area right here is not a desert. Our only saving grace is what? The Gulf of Mexico injecting moisture-laden air.